たせいたしました。それではプログラムを
Now we would like to begin the program for this afternoon. 5G, 6G Special Day 2, 5G Advancements, 6G Latest Developments and Outlook, 6G and AI. Under this title, we will have 6 speakers. First, I'd like to invite Mr. Ryuji Wakikawa, the Vice President and Head of the Research Institute of Advanced Technology, SoftBank Corporation, to present on SoftBank's AI infrastructure strategy. Mr. Wakikawa, the floor is yours. Thank you for the kind introduction. My name is Wakikawa of Research Institute of Advanced Technology of SoftBank. Thank you for this invitation. So, my topic is going to be 6G and AI RAN. When you hear the word AI, well, I think you would think that my company would not be able to survive if we're not successful in AI. So we are making a lot of investments, specifically focusing on 6G, AI RAN, and this is a slightly different area, but we're also investing into the AI foundation model, which is called the large telecom model. I'm going to explain them one by one. First is related to 6G. 6G standardization has not made much progress yet, so it is difficult to define what is 6G. On the other hand, in ITU, they have been able to identify frequency to a certain extent. Centimeter waves, 7 gigahertz band is considered to be used for 6G communication. SoftBank actually already has a 7 gigahertz site in Ginza for verifying the radio wave area of 6G. So we haven't handled 7 gigahertz radio wave, so we are testing how long it can travel. So when you look at the picture, I think you notice that we have the 7.2 gigahertz antenna right next to the 3.9 gigahertz. And this is our commercial station. So we are comparing the 7.2 gigahertz radio wave against the current commercial station. 7 is quite high in terms of frequency, so we tested thinking that it might be difficult to create an area. 3.9 gigahertz is the actual commercial station. This is an area that is covered by one station. So the area is small. We have one station per 50 meters, and some areas are covered by other stations. So the area tends to be narrow relative to the distance that 3.9 gigahertz radio wave can travel. But this coverage is sufficient when you're in an urban city. When you look at 7 gigahertz, similar areas are covered. Plus, there are areas outside the visible area. So because of the nature of this Ginza area, there are certain reflections. But in any case, this is a very encouraging result for us towards 6G. 7 gigahertz band, if this is viable, this will be a great strength for the carriers. That is a 6G radio wave related activity. And next is AI RAN. We are using AI to advance wireless devices and capitalize on this opportunity. Please watch this video.
様々な AI サービスが登場し浸透してきています。遠くない未来、社会や身の回りなどあらゆるところで AI サービスがあふれる時代が来るでしょう。その AI 社会を支えるモバイルネットワークのコンセプトとして、今まではモバイルの通信を提供するのみだった LAN と AI を融合して新たな価値を創出する AI RAN をソフトバンクは提唱しています。AI RAN とは AI のための LAN、LAN のための AI、さらに計算リソースの有効活用までを含めた AI 時代の社会インフラコンセプトです。現在、簡単な AI の計算は手元のデバイス上で処理できますが、大規模な AI の計算は クラウドで処理をする必要があるため、応答に時間を要してしまいます。高速大容量かつ低遅延な LAN と地域ごとに分散された計算リソースが融合することで HAI が実現し、大規模な AI 計算を必要とするサービスも低遅延で提供することができるようになります。HAI によって自動運転や遠隔自動手術、自然な速度で会話できる高機能 AI などの超低遅延な AI サービスが実現できるほか、地域性のある AI サービスや高セキュリティな AI サービスも実現できます。 LAN のための AI においては AI によって LAN がコード化されるほか、隣接する基地局同士を AI で連携することで電力や周波数などさまざまな高度化・効率化が可能となります。また AI LAN の計算リソースは LAN のためだけに構築してしまうとネットワークのピーク時に合わせた設計となるため、使われない計算リソースが多く発生してしまいますが、他の AI サービスと併用することにより計算リソースを最大限活用することができます。 LAN の機能を維持しつつ AI サービスに最大限リソースを割り当てるにはオーケストレーターという機能が重要となります。 AI LAN ではオーケストレーターにも AI を用い、現在および未来の計算リソースの使用状況、 AI サービスの処理に必要なリソース、全国の AI LAN データセンターの状況などを鑑み、 AI が自律的にリソースを最適に割り当てることができます。ソフトバンクはこの AI LAN のコンセプトを発表した後、2024年 AI LAN の実現や普及に向けて NVIDIA や ARM などとともに AI LAN アライアンスを設立しました。そしてソフトバンクは AI LAN コンセプトに基づいた自社プロダクトアイトラスを発表し、世界展開を目指し自社網で検証しています。AI が本当に私たちの生活に浸透し AI ネイティブな時代を迎えるには AI LAN による次世代の社会インフラの実現が重要となります。あらゆる AI ビジネスの創出を支え、その先にある人々の生活をより豊かに幸せなものにするために、ソフトバンクは次世代社会インフラの実現に向けて挑戦し続けます。
はい、ということでですね、AI LAN っていうのは、今
Thank you. So AI LAN. Well, the key message was almost entirely included in the video, but so we have a dedicated hardware, and in the actual infrastructure, we are using a dedicated hardware, and we were processing using signals. But I believe Open RAN has become quite a norm today. And radio signal processing can be done in an automatic manner because this is software based. But hardware is still more efficient compared to software, also considering the power consumption. And computing resources needed to process signals. That is why we need dedicated hardware to accelerate the process. HPA board, ASIC board is used for this processing. But if you are using a dedicated hardware and a server, maybe users would think that that suffice. But we'd like to use the advantage of software more, and AI is the best solution. If we keep using a dedicated hardware, it will be difficult to incorporate AI. So against the software radio unit, we will be able to maximize the benefit by applying AI RAN. And this requires GPU, so we are using NVIDIA's GPU servers, and we are operating the radio unit. As you saw in the video, other than the peak time, it is underused. So the excess is used for infrastructure to deliver AI for inference. in Tomakomai or Sakai, there are large data centers used for training. But in the future, when we think about service delivery with inference, AI RAN is going to be the key pillar. Actually, since 2019, we have been working with NVIDIA. So from many years ago, even from before AI started, we have had this partnership. And iTrust was announced. Software development is the essence of it. So if vendors are not introducing AI RAN, then why don't we develop it? The blue area is what we are doing, and green areas are representing the components held by NVIDIA. I believe Mr. Noda is going to present later. But as one of the radio unit solution, we are trying to release this. In Keio University Fujisawa campus, we have 20 stations that incorporates this configuration. This is the development roadmap. Currently, 100 megahertz band 44R is the scope. With one GPU server, you can do signal processing of 20 stations, which is very dense, and that really explains the power of GPU. Going forward, 6040, 64R massive MIMO, it's going to be coming into the scope, and this requires much more computing resources, and there will be many more antennas, and there will be pairing with a more number of layers, which also requires enormous computing resource. It is extremely difficult to do this with computers alone, but we are believing that with GPU, this is going to be feasible. Another thing that we have recently announced is the transformer. In the signal processing, we are incorporating transformer. Prediction is where AI is effective in terms of signal processing. Fixing a broken signal channel, or when we are tracking or following the moving pattern, AI is used. But MLP LiDAR models have been used, and we were observing the best AI solution for each use case, but we decided to incorporate a transformer this time. This is used for LLM training algorithm, and this is a very heavy process, but we have tweaked it so that we can improve the processing time by about 25%, and this has helped us incorporate it into the signal processing. Compared to legacy AI, the accuracy is also improved by 30%. In the past, there was one use case per model, but with a transformer, it can look at the entire picture to optimize and weigh layers. With one model, we can support various use cases, so this is a major technological breakthrough. Through these efforts in the future, in this area of 6G, of course, we will continue to work on radio unit, but this is a GPU server, so it is capable of doing AI processing. Isaac sensing technology also requires computing resources. And with neighboring cell, there is coordination, which also requires large computing capacity. And if we can also operate it, we'll be able to create a much larger radio unit for AI. So that is the R&D activity that we're currently engaged in, looking ahead at the 6G future. So this is the chair of the AI RAN Alliance, who is Dr. Alex. We already have over 100 members in this market. I believe we have been able to gain much more understanding for AI. And the last topic is slightly different, but I would love to introduce large telecom model. In the communication operation, we create cells, configure, construct, and when there is failure, we troubleshoot. All of these are done by engineers. And what we're trying to do is to create an LLM-like foundation to create something like an agent to share this know-how. In SoftBank, we have over 200,000 stations where we have parameters and KPIs. So we are inputting all the data for continuous training to create one large foundation model. This is a large model, several hundred billion perhaps. By using this model going forward for different use cases, we will be able to use the LTM to automatically generate and optimize base station configuration, support maintenance operation, and maximize sales. AI can be incorporated into many different aspects of operation. That is what we're currently considering. With regards to AI, SoftBank is aiming to become an AI native operator through these various activities. Thank you for your attention. Thank you, Mr. Wakikawa.
Next, we'll turn to Mr. Shinichi Isobe, who's in charge of the 6G tech at NTT Docomo. He'll be talking about the efforts toward realization of AI native 6G network. Isobe-san, please. Thank you very much for the introduction. I am Isobe from NTT Docomo. Today, I'd like to talk about our efforts toward AI native 6G network. Briefly about myself. Since I joined the company, I've been involved in research and development on the core network with focus on standardization, like emergency earthquake alert or for the access regulation. I've been working on standardization. And also in relation to AI, I worked for the management of the machine translation business company. And today I'm in the program or project to promote 6G network. And I become a project leader at the XGMF 6G network architecture. Now I'd like to talk about our activities in relation to 6G at Docomo. So we've been talking about standardization from the morning, but from last year at 3GPP, international standardization activity towards 6G has started. Currently, specific technology or requirement for the radio or wireless communication are being examined. The plan is that there will be a fixing of the specification for the standardization in 2029, with the commercial service being happening in 2030. That is our expectation. And as a background, I'd like to talk about NTT Docomo's efforts towards 6G. First is something like information providing. We have a booth of ARIB, and we have received a President Award from ARIB on the sub-terahertz project. And if you have time, please do visit the booth to see our work. Now, in the morning session, everybody was talking about the global trend being the profitability becoming lower for the network connectivity provider. But the Korean speaker said that the revenue increased by 3%. But similarly, the infrastructure investment is with a concern in relation to the investment which have been made on the G5, 5G. And Japan is facing with many of the social challenges ahead of other countries, like a shortage of labor, aging of a population, and also what to do with the energy efficiency. Those are the urgent issues. So the work done in Japan to address those issues has potential to become a role model for other countries to refer to. So given that situation, it is vital that we ought to pursue a profitability from efficiency of the construction and operation, and also it will be needed to advance the communication function to enable higher level service, and also power-related activities are needed. And for the 6G significance, Docomo identified 6 values: sustainability, efficiency, customer experience, network for AI, and connectivity everywhere. Those are the 6 values that Docomo identified. Today, I'd like to focus mainly on efficiency and network for AI out of the 5. At NTT Docomo, toward 6G, we have AI-centric network as a concept. There are 2 elements: AI for network and network for AI. On the left-hand side, you can see AI for network. This means that AI is to be used as tool to achieve efficiency in network operation. On the second-hand side, we see network for AI, which means in the 6G era, people will use AI even casually in their daily lives, and there'll be robots and those technology being active in the urban setting. Then we need to have a network that could maximize the potential for the AI to be realized. So about the AI for network, the cost reduction is a topic. By simplifying a network or automated operation of the network can be what need to be considered. So we have 3 visions for AI for network. One is to eliminate human error. Second is to achieve zero outage. And the third is maximize user experience. Compared to human, AI can handle large volume of data and also more than human. I think it will have a higher intellectual in certain areas. So by having AI do certain tasks, network operation automation can be achieved. And also in terms of zero outage, rapid recovery from large-scale disasters and network failure can be done. Also, with regards to CX maximization, data-driven network quality improvement can be expected, so that we can achieve the maximization of the customer experience. And I think those are important elements. And AI for network portfolio, there are 2 directions, one being efficiency, one being completeness. Left-hand side is about the RAN, and the right-hand side is the core network, like cell design for network design, or efficient use of frequency for the RAN, or the mobility control. Those are the areas where RAN AI is expected to be able to be used. And on the side of the core network or operation, we can expect the AI usage to contribute to operational optimization and core network control optimization. So this is one example of the AI for network. From several years ago, working with Nokia, SKT, and NTT, we are working on a project. The left-hand side shows 5G, and the right-hand side is a 6G. With a 5G, conventionally, you can see a green pilot signal. So pilot signal was needed to be added to the data so that the data segment can be analyzed. Compared to that, in the era of 6G, pilot signal is not going to be needed anymore. So the transmission side and reception side can both use AI to be able to identify where data is, which lead to throughput improvement of 18%. We have already confirmed this advantage. So we like to work on standardization of those technologies, as just mentioned as an example. So second aspect is network for AI. So the communication up until 5G was about how human use network, like telephone or internet. But going forward, human or people will use AI in their daily lives, and robot will be a natural part of their daily lives. And then all human, robot, AI, they need to be working in collaboration to enjoy a new quality of life. And for that, network is need to be achieved to serve that purpose. Starting last year, we started 6G Harmonized Intelligence project, looking ahead to a future where the robots and AI exist as a natural element of their life, coexisting with human. We aim to realize a network service that maximizes the capabilities and performance of AI and robot. You can see a robot on the very left. This is the outcome of our project together with Yokohama City. There's no cameras or sensors at all in the robot. And it's very fluffy, and the children can enjoy the feel of the robot. But while there are no sensor equipped with the robot, but the lidar and other sensing equipment are to be arranged surrounding the robot, and then the sensed information will be shared with robot. So data is to be shared through the network, and that will be analyzed with AI to control the robot. In the center, there is about the autonomous symbiotic robots. Recently, we hear a lot about the damage from bears. If we have those robots in mountainous areas, those robots can send a location information for bears, with which the AI can analyze to come up with a prediction for where the bear may appear. So this robot is at the booth. It's in 2H2. H2, I believe. So if you have time, please do visit. Now, so we have developed those concept robots. Robot and human and AI, when they are to work in harmony, to realize that, what are the issues that need to be tackled? So we need to have a network which is optimized for communication for robots and machines. Human will sense the delay of the data with a 20 millisecond delay. But is that delay important for robots? Is jitter maybe more significant for robots? Those are the things that we have been studying. And also, with the earlier robots, they only limited the resource be able to be used, like a CPU or GPU. But with network, the cloud data center can be leveraged. So those cloud resource can be used as a brain of the robot. And so we expect that there will be a situation where robot is to take actions communicating with those cloud-based brain. And we've been working on the technology called in-network computing for several years already. So this is about the reduction of the load on the terminal, and is expected to also save power by offloading information processing from the terminal to device. So in this example, where the wearable terminal or wearable devices are to be used, the resource equipped with the wearable device may be limited. So in those cases, we can have a processing of information on the application server. So this is a potential use case. And an example of robot that I talked about earlier, let's say local robot takes place of the wearable device in this side, then some of the data processing can be done by the application server, making the robot act based on the analytics. So the idea here is to have a smooth collaboration or the linkage between the application server and the end device, and this is what we are aiming to achieve. So towards 6G, We are now developing those technology elements so that the human, robot, AI are to work together in harmony. And we like to a contribution from the 6G network front to that. That concludes my presentation. Thank you very much.
Mr. Isobe, thank you very much. Next, we will have the presentation from Rakuten Mobile. Mr. Mitsuhiro Kuchitsu, who is the General Manager at Innovation Program Development Division at Rakuten Mobile. Mr. Kuchitsu will discuss smarter Open RAN for the beyond 5G era. Thank you very much for the introduction, and I'm so much honored to be given this opportunity to speak in front of you. Now, at Rakuten Mobile, we are also working on communication and NI, so I would like to talk about our effort in this area. But first of all, here's my introduction. I have been working at Rakuten Mobile for years, and I have been working on the standardization of virtual RAN and 4G, 5G of multi-vendor configurations. And also I have contributed to Japan OTIC establishment, which belongs to ORAN Alliance. And also I'm looking over the innovation project development business in our company. And also I am a manager for Japan OTIC and supporting in and outside of Japan ORAN, open ORAN efforts, promotion efforts. So first of all, I would like to talk about two things today. One is our initiatives at Rakuten Mobile related to AI, and also would like to talk about the use of AI in the next-gen network. Now, regarding our network at Rakuten Mobile, as I have been talking about all the time, we are basically promoting 100% virtualization and cloud take-up. And by doing so, we are trying to really reduce the operation cost and also configuration cost. What's important is, as you see here, the vendor close to consolidation, vendor concentration in RAN market is something that we have to leave behind. This is something that we have been working on at Rakuten too. So the reason why we talk about adopting mobile and RAN, this is very significant for mobile network. Let's say on the left side, you see the AI based architecture that is not really open. The models are closed, so it is not open at all. I mean, even if the network tries to become open. So we are trying to make AI native mobile networks so that we will have the open interface. When we talk about this kind of things, people might get the impression that it's just after thought. But now as you can judge from Open RAN name, you might think the purpose of doing Open RAN is to make the thing open, but actually, and you see the lower the number is, the more importance we attach to it in the working group numbering. So if you see working group number 2 and 3 are actually related to AI. So from the very beginning, Open RAN initiatives have started with the objective to use AI for the control of the mobile network. So we have been working on the virtualization and making the RAN more open so far, but these have been just first stage because the most important phase for us will be the adaptation of AI in the network management. Now, when we use the term AI, people tend to think that AI control probably means also control by a third party and also less security. And this is often the voice we hear from different operators. So in ORAN Alliance, we also are trying to improve the security in ICT's project. And also the RAN intelligent controller is used here, which is in compliance with the standard organizations. Regarding the RIC project, NICT booth actually exhibit this, so I do hope that you will take a look at it there at the NICT booth. So I talked about the evaluation of security and also the base station power consumption reduction. These are things that we have been working on, but also the same thing applies for cloud. We want to make the cloud resources open. They are already open, so the traffic conditions and the prediction of traffic are basis for the changing of the better paths so that we can reduce the power consumption. And also when the traffic is lower, then the freed up resources can be used for other purposes. So this kind of basic researches are also going on. Now, when we talk about AI and the use of AI in RAN, this is still in POC stage, you might think. But the other day, we made a press release that all the things that I talked about are already in use in Rakuten Mobile. The first target, well, there are many different use cases. Let's say AI can be used to predict security problems. But the first topic for us was the power consumption reduction through the power of AI and RAN. And I always believe and feel that even if you have the AI model, it is difficult to prove it, and also it is necessary to keep it trained. So, in a way, the deployment in real world is a must. So we want to actually put it in use in real world, so that the prediction we have gained in the test are actually correct, and then we do the iteration. And by putting into the real-world deployment, we have confirmed the effect of the OPEC reduction, and we have introduced like thousands of models, and we want to increase the number to 10,000 or 20,000. And also in terms of operation, in the past, many things were written by manual work, but now the models can learn so that the most optimal parameters can be set, so the operation cost can be reduced. We have confirmed this effect or impact already. Now, I have talked about the efforts at Rakuten Mobile on AI. Secondly, I would like to talk about the AI usage for 6G. I would like to talk about our future direction. Now, so the way we think about AI in communications is something that I will talk about by using its information coming from MIC. As Mr. Wakikawa pointed out earlier, and Mr. Isobe talked about, AI is going to be very important in 6G. And also, I want to emphasize that we agree strongly with these two other companies, and we are heading in the same direction. But on top of that, I also would like to emphasize that now AIs are used in different parts of the network, but because the AI is used in different domains of the network, how to consolidate or how to integrate them is going to be very important. For example, talking about the AI models integration, it is a little bit overlapping with what the presentation of Docomo talked about. Now, today, there are AI used in cloud, AI used in base stations, but also would like to use AI in edge or applications more. This is something that we're already actually working on. On the right side, you see the proving test of the AI usage in autonomous, and also on the left side, you see example of the live streaming, the video streaming. So how we can integrate different AIs of different layers. The important point about AI is that matching different types of AI to different types of use cases is very important because requirements are all different. Even if you want to, sometimes you want to use LLM for everything, it doesn't work because the needs are different. Talking about robot example earlier, if certain physical actuation is necessary, if the physical problem related to physical actuation or the physical network cannot be solved, development of the LLM from the core doesn't work because it has to be closer to the edge. And also, if you have the LLM in edge for everything, that will require excessive cost and excessive power consumption. So allocating, placing LLMs appropriately by distributed manner is very important. And security purpose AI and communication purpose AI are two good examples because on the side of the security for proving the effect, we are working with Vissel Kobe Football Stadium, and there they receive a lot of video, but they don't have enough people to monitor and analyze all the video data. So in that case, edge AI can be used. First of all, they can use the edge AI to remove all the normal video because normal video is basically empty room video for hours where there's no thieves or no intruders. So by removing the normal parts of the video, they can condense more interesting video only for the people to see. And also, in order to do that, we would need communication to send, or the network to send it. And to ensure accurate video sent over distance, you would normally need a lot of time, and also at time of congestion, that means delay, or latency. So using AI-powered communication, we will be able to use techniques such as slicing to ensure fast delivery or the transfer of video. Now, another example is I talked about the use of AI in edge, but also transport also would require AI because base station is connected to fixed lines, so fixed networks. So the fixed work transport can be managed by AI, and that can be integrated with the AI on the edge. And by doing so, we will be able to have, for the first time, the more efficient management. And this is something we talk about in ORAN Alliance. At ORAN Alliance, they often think about the AI in RAN and also core network, but actually they are also responsible for network transport network. So we included here the transport network management, and by doing so, we are able to connect the core network and RAN. Because and before there was AI in RAN and also AI in transport, two different AIs. But now, instead of having slicing being done not in the edge but in the transport, we can enhance the efficiency. But for that to happen, there need to be integration, and eventually this effort will lead to integrated AI. Now, talking about AI in 6G, this is the work items organized by 3GPP discussion. And again, at 3GPP, they do talk about AI in 6G. Energy saving is one example, but also NTN or satellite direct communication is also another very important topic. Now, the things that we have been working on in the past can be used in 6G development, and also what we have learned over the years can be taken advantage of in full-fledged manner. Before the standardization is fixed for 6G, it is important to contribute our ideas to them. So that way, we, Japan can have a winning opportunity in 6G. Now, as of today, as I said earlier, AI discussion and 6G discussion are at their peak, and the standardization effort are to start. And now, today, 3GPP and ORAN Alliance are talking with each other, working with each other. So what we are doing in ORAN Alliance, we believe will be incorporated into the standardization in 3GPP. And so we would be committed to proactively contribute to 3GPP discussion from ORAN Alliance. Thank you very much.
Thank you very much, Mr. Kuchitsu. Next speaker is Dr. Toshiaki Yamamoto, the General Manager of Wireless Technology Division, KDDI Research. The title of the presentation is Innovations in AI for B5G/6G Networks, KDDI's Challenge. Mr. Dr. Yamamoto, the floor is yours. Thank you for the introduction. My name is Yamamoto. I am the head of Wireless Technology Division of KDDI Research. So I would like to appreciate for this invitation to speak at this forum. This is my brief introduction. I joined KDDI in 2004. Since then, I have been in KDDI Research studying new wireless communication methods. In 2015, I was transferred to KDDI headquarters to plan and develop 4G and 5G base stations, which was closer to our clients. In this April, I returned to the institute, and I am now promoting R&D towards 6G. This is the agenda for my presentation today. First of all, as you are aware, communications and AI are becoming indispensable elements of today's society. By blending these two, we need to create new value and accelerate problem solving. This is satellite growth strategy, which is the business strategy of KDDI. In the middle, we have 5G communication and data and generative AI. Communication and peripheral areas growth are to be accelerated in our business strategy. On top of that, we have the AI business. NVIDIA's latest GPU is something we are using in our investment of around 100 billion yen to build an AI data center. And we are aiming to start operation by the end of 2025. We will be offering an AI platform and using the high-speed, large-capacity network of mobile operator as well as operational know-how of ours. We are aiming to accelerate the AI development of our customers. Next, I will talk about the supporting network. In terms of 5G network, from a third-party evaluation body, we have received a #1 evaluation for communication quality. I believe that if you're using KDDI, you're feeling the improvement in the quality. And we have started the international service ahead of others. We have AU Starlink Direct, which is a direct communication service regardless of where you are. High quality communication is available anywhere in the world, and we believe that we can be proud of this already available infrastructure for AI. This is showing the increase of AI traffic. This is a data from Nokia. The left graph is showing the years horizontally and traffic vertically. Blue is representing conventional traffic increase, and green, orange, and pink are showing AI-related traffic increase. As you can see, the percentage of AI traffic is expected to grow continuously. Therefore, preparing for such exponential growth in the future, we need to prepare with a better network. As our activities to support such enormous traffic, we have AI for network and network for AI. In terms of network for AI, data centers, infrastructure construction are the main topics, which I already covered. We are using AI for better efficiency and quality in terms of AI for network, and that is what I would like to cover in details going forward. Next is related to AI utilization R&D. This is the trend of standardization. In 3GPP, 6G standard is going to be, or standards are now being considered in 3GPP. Network operation optimization and using AI and ML for optimizing operation of the network are something that they are aiming to realize. In terms of ORAN, in KDDI, utilizing AI ML, we are trying to promote the performance improvement, power consumption reduction, and automation of RAN. We are using SMO and RIC to deal with multi-vendors with the view of standardization. Based on such situation, we are using more AI in the context of RAN, and I believe there are three aspects. One is signal processing, improving performance of signal processing, improving efficiency, and reducing power consumption. Second is related to RAN operation, detecting failure, automatic recovery, and automatic optimization of base station configuration are the purpose. Third is radio propagation prediction. This is related to area design and basic evaluation for securing new frequency. For each of them, we are showing the current status and a future approach of KDDI. The important thing is it doesn't mean that we can only use AI in 6G, but even in the current environment, we are starting to use AI effectively. But in order to further advance such utilization of AI, we are researching and developing toward 6G. Now I'd like to go into the details. First is improving the performance of wireless signal processing. In 3GPP, they are considering applying AI ML to various use cases. This is my favorite topic because I am well versed in RAN, but today, because of time constraints, I shall only focus on one use case. I would like to introduce this use case. This is related to application to nonlinear distortion compensation of broadband amplifier. As one of the options, terahertz band usage is being considered. In such high frequency bandwidth, when we use super broadband amplifier, we will have nonlinear distortion. as you can see at the bottom right. That is already known, and using AI from the sender side, we like to compensate in advance so that we can send a beautiful constellation. This is not a simple application of AI, but a neural network is being adjusted so that we can reduce the computing amount on the AI side while compensating for the distortion, and that has been confirmed in our POC. Next is related to the operation of RAN. I think this is an easy to understand example. In order to reduce time from detection of failure to recovery, we are aiming to apply AI for automation. In KDDI, we have been able to automate up to failure detection using AI. Causal analysis is currently under verification, and ultimately, we like to accomplish automatic recovery. This is related to autonomous network to realize customer requirements. In the past, we were using something like craftsman skills to do tuning, fine-tuning of base station configurations, but we would like to create a knowledge database and train the LLM so that the operator will be able to learn what measures they should take for certain events using natural language questions. As a result, we will be able to improve efficiency, and also we will be able to be more consistent. Next is optimization of base station configuration. Regarding base stations, we have several 10,000 base stations across Japan, which has several thousand parameters for each of them. To maximize the communication quality of customers, we need optimization in response to the specific situation of each cell. But there is a limit to what we can do manually, and we've only been able to optimize the tip of the iceberg. By using AI, we are trying to improve and respond to parameters that cannot be adjusted manually, and also to optimize for a respective cell and to follow variations in terms of time. We are also proposing reinforced training algorithm suitable for RAN. RAN optimization is always about solving a combination problem, but using a reinforced training algorithm compared to the conventional one, it has fast conversions with less computing amount. Next is wireless digital twin expectations. So this is related to radio propagation. In order to cope with the diversifying service environments and communication requirements, we have high expectation on utilization of digital twin. To that end, in a virtual space, it is important to accurately simulate the radio propagation in certain space. We are using AI to design an area based on a radio wave propagation model. We are applying the image recognition technology to identify the building information around the sending point and the receiving point to build a suitable radio wave propagation model for each location. And this is the measurement that's done in Minato Mirai. So we are comparing a model with AI versus the one without. As you can see, when we use AI, we are able to estimate AI appropriately. With this, we have high expectation on the utilization of digital twin. This is the final chapter. I like asking this question, so I like to do the same here. When AI made a decision to cause network failure, well, I want to ask our customers, can you forgive this AI? I think no one will say yes. If there is a failure and if our CEO said that it is the fault of AI, we don't want to see that. So for carriers like ourselves, in order to be responsible for operations, we need to be able to explain what is happening and why that was caused. So being explainable is crucial. So when we think about that, applying AI to pioneer uncharted territory carries risks. That is my personal impression. So for the time being, we believe we should focus on automation of existing tasks. But if that is the only thing we do, we will never be able to maximize or fully demonstrate the potential of AI. Finally, in order to use AI safely and in secure manner, reliable operation is going to be the key. As key point for standardization, we need to have a system or mechanism to monitor if the AI is operating appropriately, and if not, we need to have a mechanism for fallback to processes that are non-AI dependent. Also, operators need to have a deeper understanding of AI functions and AI systems so that they can better operate AI. That concludes my presentation. Thank you for your kind attention. Dr. Yamamoto, thank you very much.
Next, we are to hear from Makoto Noda-san from the Telecom Business Unit of NVIDIA Japan under the title of the Outlook of the NVIDIA toward AI native 6G. Good afternoon. Thank you very much for the introduction. I am Noda from NVIDIA. I am at the Telecom Business Unit of the company. So I'm working on developing and enhancing technology-related relationship with our partners. And I am very much honored to be here as a member of the speakers from the company, which is a semiconductor supplier. And as 6 people or 5 people are to speak on the same topic, there are some of the topics which have already been addressed by others, but please do assume that what I say is said for the first time. Now I'd like to talk about the outlook of the NVIDIA about the AI native 6G. So first of all, why NVIDIA is involved in communication? Maybe you would wonder why. And you may think that we are only the semiconductor player. So first, I'd like to explain our relationship with communication. Starting from the left-hand side, what does this mean? This is the computation amount needed for deep learning. Blue line is before transformer situation. So this is the volume required for the learning by the conventional model. But the green line is after transformers. So before transformer, so every 2 years, the computation volume increased about 8x. But after transformers, in 2 years, the computation amount required increased by 256x. And there is a scale role for AI, as there are many more parameters for model, AI becomes smarter. So we believe or expect that there'll be increasing parameters going forward. And we believe AI and RAN share a common affinity with GPU, so that is why we are involved in the communication. Now, turning to the right-hand side. So this is from the blog of Ericsson. This shows protocol process amount by protocol layer for the 5G stations, like frequency, capacity, number of antennas, or the calculation requirement becoming tighter. With those, we can see that the processing need increase exponentially. And a dominant factor is beamforming or a lower protocol layer processing. And those are good. Those workload are in affinity with the parallel processing. And so the characteristics is that the RAN-related AI processing is easy to be handled with GPU. So that is why from 2019, we have started working on the RAN. Now, going into the main topic. So when media cover our company, you see a gray hair gentleman in the leather jacket, Jensen Huang. He's our founder and CEO. And this slide features the comment made by him. 6G wireless networks are to be quite revolutionary. Why? Because this presents an opportunity to ensure AI built in from the start. Actually, this point is not made only by our founder. I think that similar things are being considered by other people in the industry as well. So 6G is to be the first AI native network, and I put together some information about the AI native 6G comparing against conventional networks. So key points are the following. So when it comes to the conventional network, they had a single purpose, but the AI native 6G will be a multi-purpose AI network. And then there'll be a transition from hardware software being highly coupled to 100% software defined. And then there's also a shift from static air interface to dynamically learnable interface. And then in terms of traffic, there'll be an increased AI traffic. And in terms of innovation cycle, with the concept of a CI/CD, the innovation cycle is to be much shorter. And then lastly, with all those elements, ecosystem would become close to open, so that the more innovators are to enjoy opportunities to participate. So this is the NVIDIA's view about the AI native 6G's features. Now I'd like to go into more detail so that we can consider what would be achieved in future based on our view. So millimeter wave, semantic, ISAC, those are the what are characteristic about the 6G. And by combining them with the AI, we believe that the performance of those elements can be doubled or even tripled. Like ISAC, they are to be used as sensors, but by using AI for communication process, like this is the use case of AI for RAN, but we can combine them with ISAC. Specifically, the sensor information of the surrounding environment captured by ISAC could be used for the online training in a real time to come up with a network environment which is suitable for each specific site. And we think that that could be possible. And AI for RAN approach together with orchestra and such. We believe that AI native 6G is to help achieve the greatest spectrum efficiency much better than the ones before. In 2020, compared to 2020, we believe that the spectrum efficiency can be improved 40x. Towards such AI native 6G network, also hardware, there are things that we're focusing on, so I'd like to share with you. So cinema and aerial are the application frameworks that we provide. What do we do with them? So AI is to become incorporated to the network, and the neural model is to be prototyped and trained. And there are functions for that to happen that we are providing. And the model, as a result of them, will be fed to the tool for the simulation, which allow a further fine-tuning. And the model is to be deployed as a commercial system. And for that, there'll be a SDK, and there'll be a GPU-equipped hardware. And like this, we provide a end-to-end system incorporating both hardware and software elements. So while we provide such a platform, working with the GSI partners, OEM partners, or the communication players, other network players, we work on the research and standardization for the next generation network as much as possible. Our efforts may not be well known in this area, but like at the 3GPP or Forum Alliance or with the AI Alliance, we are actively involving in activities in those forums. And I'd like to share with you one of the example overseas. In June, we made an announcement about our MOU with the Department of Science, Innovation and Technology of the United Kingdom. With the major universities in the UK, we're working together to promote the standardization and the development work for the commercialization. And what we contribute is for the development program and research kits. By providing them, we are backing up the initiatives by DSIT, the department. And then another example, IIP is the research department of the university in Zurich, and we're working with them towards 6G. New baseband processing algorithm development and verification is the nature of this work, and we are involved. Specifically, with beyond 5G and 6G, uplink will become more important, and the receiver side processing is to be helped with the neural network, and not just with simulation, but with the actual equipment. We will be testing the method. On the right-hand side, this is the activity in the United States. So this is the project with the code name of AI Win. We work with the group of American companies. And what is the project about? So this is about developing an AI native wireless network stack for 6G. And the idea is not to deploy only in the United States, but to deploy it globally. This is a very ambitious development project. I already spent about 11 minutes, 12 minutes. Good news. What I said is captured in 2-minute video. This video may have played my role, but in order to secure my job, I talked instead of showing the video first. For the recap, please do follow the video. This is with English audio with a Japanese subtitle.
The journey to AI AI-native wireless networks has begun. Traditional wireless systems rely on fixed algorithms that are hard to scale and slow to adapt. NVIDIA AI Aerial changes that. Neural networks learn from data, adapt in real time, and scale with complexity, boosting spectral efficiency, lowering costs, and improving connectivity. Building AI-native wireless networks takes 3 key steps: training, simulation, and deployment. NVIDIA AI Aerial unifies all 3, making it easier to build, test, and deploy AI models faster. Here's how it works. We train a neural network model using NVIDIA Shauna and aerial radio frameworks. This model replaces the traditional 5G channel estimation algorithm. Next, we simulate and optimize it at city scale, testing thousands of real-world scenarios in the Aerial Omniverse digital twin. The result? Nearly double the cell throughput with AI on. Then, we deploy the trained model on a live 5G network at NVIDIA using Aerial RAN computer. The result? 100% higher throughput with AI. Because the model connects to a digital twin, it keeps learning, continuously improving over time. This feedback loop between the physical and virtual worlds helps the AI evolve faster and get smarter with every cycle. With the Shauna Research Kit on NVIDIA Jetson, developers can go from code to a working AI model in a live 5G network in few hours with just 6 lines of code. This is just the beginning of AI-native wireless networks. As models improve, they'll boost capacity, unlock new applications, increase efficiency, and extend coverage to more people. Join the NVIDIA 6G Developer Program to accelerate your AI-native wireless research.
はい。きっと最初にこれを見せてくれようと思ってた方がいらっしゃいま
You
す。
might have thought that I should have shown this to you before my presentation, but that's what I did, and this concludes my presentation. Thank you very much. Thank you very much, Noda-san.
Finally, we would like to have Professor Akihiro Nakao, who is the professor at Graduate School of Engineering at Tokyo University. And Professor Nakao will talk about the next-gen cyber infrastructure shaped by the convergence of communication and AI. So I've given 5 minutes, and the other speakers were to talk for 15 minutes. I'm just giving 5 minutes, but there's only one thing I would like to talk about. Now, in the past, the carriers and semiconductor companies talked about, probably because you focus on the communication and AI, and many of you have got the impression that we have overgone this stage already. But if you look at the title of Mr. Noda, who just spoke, he talked about telecom business unit, and you see that semiconductor industry people look very attentively to the industry of communication, and that is why their technology is now being used by communication industry. So today, I'm going to talk with my cap as a university professor on what does a university do? What does academia do? Well, we're not there just to propel the monetization of the technology, but also we need to educate people so that they would incorporate the technology into all the processes and also into the education, because the workforce generation will stop. Now, in my lab, we often talk about communication and AI. And probably I don't have to repeat what's written here. We work on the energy savings and creation of business and services values and network efficiency enhancement. All those things will receive contribution from AI, for sure. And also talking about the global collaboration, as Mr. Yukikawa talked about, we are the first university in Japan to participate in AI Alliance, and we are contributing to the international discussions, debate, and standardizations in the world of RAN and AI integration with RAN. Now, regarding the beyond 5G, the usage of AI has been the assumption from the design stage. And so AI is going to be used in each layer of the beyond 5G. And we are intending to develop a 6G mobile system prototypes that uses AI, especially talking about the collaboration between industry and academia. You might think that and actually I am so happy that today we have brought together all the people who I respect so much in the area of the collaboration between academia and industry. And we also believe that Tokyo University has a role to play in building future society infrastructure. As Professor Wakikawa said earlier, this AI alliance stretch not only stretch beyond industry. Universities do participate, and before Wakikawa-san talked to us, we didn't understand that either. But listening to the elaborate explanation, we realized that there will be a very important role for universities to play in AI RAN Alliance. And that is why we decided to participate as a founding member. And actually, these days, our students do understand this. Every week, I have a lab session for 5 hours. You might think it's too much for the students, but I often explain how AI and communication are interrelated with each other to students. And Mr. Wakikawa and Mr. Yamamoto prepared the environment for them to use the NVIDIA's Aerial stack to build the control for RU and to build a designing a system. And so they are able to build a very sophisticated technology using this technology. So this is one example of how I'm trying to ensure that the next generation engineers understand all this. Now, we are trying to work on the 6G mobile system optimization through cross-layer multi-domain AI integration. This is called 6G Mirai Harmony. We work with between NIC's Harmony and also EU's Horizon Europe 6G Mirai. And there is RAN Intelligent Controller RIC created by All-RAN Alliance, and this is also used. So I think we're running out of time very quickly, so maybe the panelists can get prepared to be stepping on the stage, but I'm running out of time quickly. Therefore. But anyway, in this project, well, actually, it's been only 6 months since we started this project, but students are very much engaged, and they already had these papers already adopted. That means they wrote more papers, of course. And also, I myself wrote 4 papers. And so because I wrote 4 papers already, students unfortunately don't have any more excuse to say that they're too busy to write a paper. So I just wanted to share with you how much we are interested in actually doing a lot in the university too. So we would like to have all the speakers in this session as panelists, and then we would like to really deepen the discussion. I will stop now and like to have a panel discussion. Thank you. Professor Nakao, thank you very much. So now let us start the panel discussion. the business opportunity that AI brings to communication in the age of 6G. And this is something that we would like to have. And also the facilitator will be Professor Nakao from the University of Tokyo. So I hope all the speakers or the panelists will be on the stage ready for the discussion. Thank you very much. So Professor Nakao, please. So thank you, but we are running out of time very, very quickly. So let me just jump in the discussion. And the title here is the business potential that communication and AI can bring. And so many people are interested in this combination. There are three items that we would like to discuss. Maybe we can cover at least two of them. First is something that we have already talked about a lot. But I would like to ask each one of you about the trends in the AI use in communication industry. And you might have some ideas about one or two specific areas where you are trying to accommodate or embrace the use of AI. It could be operation or network management. Mr. Wakikawa, can you start off? Thank you. So we have been working closely with NVIDIA for many years, and the RU is now a software. So there can be different types of innovations happening. And Mr. Jensen's words were quoted. Working with NVIDIA, something that I was really impressed with his words is NVIDIA is a software company, he said. And so to run a software, they're building a hardware. So the value is really in software, he said. So putting functionality in software, the speed of innovation is accelerated. And actually, that is very evident in AI-powered RAN. And also, the RAN also can be enhanced as AI enhances. Unfortunately, up to 5G, operator focused on cost operation. That's what we needed to do. Because of the lack of the money, we didn't have any innovation. But now, we are riding on a wave of AI. We will be able to use money to create profit-generating platform. That is something we would like to do at SoftBank. And I'm sure outside of NVIDIA too, there are people who understand this. By having more basic, foundational technology advancement, there are more things that we can do. In case of software, we are investing in many areas, but probably the semiconductor holds the value, and how much information we can have reflected in the roadmap will determine our next steps. So be it business side or technology side, there are many development, but we are really partnering up with many people to achieve the goals here. Thank you. So computing and communication convergence fusion was also talked about today. And actually about 20 years ago, what was done on terminal, maybe we can put it into the network flow. That's something we worked on. But at the time, we had only do the functionality of the Windows terminal desktop. It was too much for us to do the latency shrinking. But in case of 6G, the latency can be very, very low. So it is possible to put the terminal virtually on the cloud. So computing and communication is getting closer with each other. And with this coupled with that, maybe we can advance the AI even further. That is the future that we are heading to. There was a mentioning about the network that was interesting too. Thank you. Yes, as Mr. Wakikawa just said, I think we are seeing the trend where functionalities are putting into functional softwares. And there are many use cases that we can think about in AI. And where you should use AI is key. One example is light AI, light a model for lighter tasks and heavier, bigger task models for more important, more heavy tasks. And so when it comes to AI, I think there's a huge potential for Japanese industry because when it comes to operation, for example, people talk about great performance is great, but in terms of availability in Japan, the availability of Japanese operation is very high. I know you've been to other countries, and there are not so many networks around the world which has the same availability as you can experience in Japan. Well, this is really due to not only to people like us, but to KDDI, SoftBank, and Docomo. We all share a very high skills and proficiency of operations. People we've been doing this manually, but they can be done by AI, and I think we can have huge potential for productization. And we do own that technology and know-how. So I think we can use AI to create business opportunities for Japanese industry. Thank you. Mr. Yamamoto, please. Thank you. Now, at KDDI, as I said earlier, we are running AI data center business. KDDI is a communication company, and people wonder why we have to expand our business. It was a surprise for me too, very beginning. But when we talk about the convergence was communication, having data center services supported by a very solid infrastructure that, or the communication that carrier has, we will be able to provide value to our customers. Mr. Noda, I have a request to you. Telecom unit. Can you talk about the size of the telecom unit and the future of the telecom unit that you belong to? Can you talk about that? There's been some questions to you about that point. Yes. Within NVIDIA, telecom unit is a team I belong to, and the creation of this telecom unit was actually when we were establishing the VRAM business with Mr. Wakikawa. So it was like in 2021 or so. And now the number of the people was, I don't know if I can share that with you, but it's not very big. It's not very big. Just dozens of people. So it was about 2019, it's around that time. But the number is growing all the time. And I am betting on the business opportunity of this telecom unit, and we would like to expand this team. Thank you.
Thank you very much. In the presentation slide, there was a logo for the university collaboration, and I didn't find University of Tokyo, so maybe you can include it next time. Well, we are running out of time, but surprise is a good thing about my panel discussion. So I would like to ask a question to the two of you. So I trust Symphony ORAM-based things were introduced in your presentations. So these are the things that vendors used to do. And I think there's kind of a trend that carriers are doing more of this. So can you please briefly tell us about your take on this? Especially on iTrust, what is your expectation going forward? Yes, in that sense, currently we are pursuing innovation, and by doing it internally, we are trying to accelerate the speed. But when commercializing it, we need to care about being carrier graded, and there are other hurdles that we need to clear. So we also have that in our mind already. I ran Alliance, that is a community we've established, and through that forum, we are hoping to give feedback to vendors, or we can become a vendor and then use the service. There will be many options depending on the situation. Thank you for your answer implying a lot of things. How about you, Kuchitsu-san? Well, Rakuten Symphony already has base stations around the world. I personally have talked about Rakuten Symphony to many operators for expansion, but to be honest, I have faced difficulties. I used to only explain that this is affordable, but from other operators' point of view, maybe it wasn't attractive enough. They may choose to stick with the current solution, and the replacement cost will definitely be higher. So I believe 6G is a great opportunity. We are speaking to many operators, and we have a good understanding of what is the gap. And software-based and AI, we can sell this as a package. So we like to take advantage of the current trend. And in Rakuten Mobile, with the track record, we would like to strategically expand the sales overseas. In Kuchitsu-san's presentation, you showed a pie chart of the market share of base stations. And when I combine that with Noda-san's presentation with O-RAN and AI-RAN, the government regulator and vendor telecom carrier, I was imagining that this landscape can dramatically change. And this is not a question, by the way. Well, I also think that this can change. Market share will eventually include software in addition to hardware. So, including NVIDIA, there are many players coming into the picture. I believe there are vendors in the audience, so I think we should stop it here. Then let us move on to the next question. This is the question that I wanted to ask you today. Communication combined with AI, that is a very active topic in the academia world as well. But what do you think about the possibility of incorporating this concept into business, and when is going to be the timing? We often call this the day one, but what technologies do you believe will be practical for day one, Noda-san? Yes, AI-RAN is one of the pillars for our business strategy, as I explained. AI-RAN has 3 use cases: AI on-RAN, AI n-RAN, and AI for RAN. Regarding AI on-RAN, we can easily narrow down the target and start small. SoftBank's iTrust is already demonstrated at NVIDIA's headquarters. So the timing of incorporating it into business is now, maybe. And AI on RAN will be practical for day one. Today, AI on RAN has been one of the themes. So Wakikawa-san explained the GPU for both base station and AI inference. And this is specifically about AI inference that you said will be practical for business. Okay, then can I turn to Yamamoto-san? I'm not sure if I can call this a business, but in the same way, AI for RAN, AI for network, in this area, from the day one of 6G, it will be incorporated as elemental technology. And from the viewpoint of an operator, operation efficiency and performance improvement will be the areas where we can take advantage of AI. And from this era of 4G and 5G, we need to accumulate the track record of using AI appropriately so that we can demonstrate the full potential from the day one of 6G. Thank you. So you said that it's already been incorporated. Thank you, Kuchitsu-san. I explained it during my presentation, but RIC AI RAN is already incorporated in the commercial network, so the timing is already happening. That's my answer. When we think about AI, energy saving is our emphasis. There are many use cases, but we placed particular importance on energy saving because even if we proposed for traffic steering, it's difficult to explain how it will lead to revenue generation. When we tell operators that they can reduce cost with AI and explain that this will help them reduce communication cost, they become very interested. As a business, what is valuable? That needs to be well understood. And if there's something of high priority, that's where we should start, eventually expanding to the subsets. Thank you. I believe you all have a positive outlook. How about you? Of course, please feel free to give us negative comments. Well, there are no negative factors, actually. In terms of standardization from 5G phase, energy saving, and wireless control on the network side, from position information, prediction of behavior have been standardized. And in 5G, from the day one, there was no AI, but it is treated as an add-on. But in 6G, AI will be a native function from day one. And we often talk about autonomous operation, be it level 3, level 4, 4 point something, but it will definitely be incorporated. Thank you. Well, other speakers already covered my point, but AI RAN, what is it? When is the timing? That's a frequently asked question. But the business and deployment readiness are two different things. In most operators, they have tens of thousands of base stations, so they need to do depreciation to introduce RUs. If this can be treated as extraordinary loss, we will be happy to deploy, but otherwise it would take a longer time. And in terms of new frequency, this is only a question of timing. So there are several factors. So business decision and technology are not necessarily aligned. I hope you can understand that. On the other hand, edge AI and non-RAN factors, these are the things that we should be working on already because they are already AI ready, and we're striving for realizing those concepts.
We have persons from the officials from the ministry today, so I believe that, or I hope that what has been said is resonating with the officials. I want to move on to the question 3, but actually I had a hidden question which was not pre-shared. This is a simple question which can be addressed by yes or no. So AI, going forward, everybody was positive that AI is to be incorporated in business, but when it comes to ARPU, I know many of you are familiar with the term, revenue per user. So how much profit can be gained from the users? But we've kept hearing that the ARPU has kept declining. But would AI help us improving ARPU? Please give us a yes or no answer. Oh, it's difficult to answer, but I would say yes, positively. Great. Yes and no. When it comes to traffic, as mentioned by Nokia, the generative AI traffic is to go up. So I would say yes from that perspective. But what would be the pricing plan that would have a big impact? Right. That was the answer that we expect from NTT. So I'll say yes, but I have additional comments. So price for subscribers, the price is to be maintained. So I think that's the mission of Rakuten Mobile, to maintain an affordable price. So with AI, our mission is to maintain affordable price. That's our mission. Yamamoto-san? Yes, I also say yes to the users. We believe that we'll be able to provide a sufficient added value. Noda-san, you are not a telecom operator. So in terms of the semiconductor sales, how much increase can we expect from communication? Well, NVIDIA does have a telecom business unit. So we do recognize a big business opportunity in this area. Well, thank you very much. Well, thank you very much for responding to my radical question. Now, lastly, this is a request. So you made many comments. So in the XGMF, we have a AI working group. And I had a conversation with the Wakikawa-san before, but I was not able to say this to other speaker in advance because I did not have enough time. But what I hope is to continue this conversation after this today's occasion. I was thinking where we can come up with impact, but maybe we could put together some kind of article with the theme of the telecom and AI and semiconductor. So I'm not going to ask you a question of are you going to join, but I assume that you will all say yes to my question or request. Please give a round of applause to the speakers. Thank you very much, Nakao-san, and panelists. Please give a huge round of applause to the speakers once again. Thank you very much.
ありがとうございました。以上で本プログラムは終了とさせていただきます。ご出席いただいて